This video is all about event systems, and specifically how we can use event systems in Unity. And to give you a little bit of background, in video games, like really all programming, we want our program to respond to changes in the environment. So, for instance, when a user hovers over a button, we want it to respond by, say, changing color. And there are two major ways that programs can respond to changes in the world. And these are polling and events. And with polling, an object checks the state of the world around it at some regular interval, and then it responds to those changes. On the other side, with events, an object sets up a listener with some kind of control object. So our object becomes a receiver of events. And when the state of the world changes, the control object then checks to see what objects are affected, and then it sends each one a message or an event letting them know. So the difference is that an object is either actively checking for changes with polling, or passively waiting for an event with event listeners and event systems. Now, some object in your program is always going to be polling. Something's always going to be checking the state of the world regularly and responding to those changes. But with event systems, we can push this to a single control object, instead of every object in our scene having to have the same check. That's a lot of overhead, that's a lot of sort of unnecessary stuff going on, so that's the advantage of events and event systems. With the new UI system that was introduced in Unity 4.6, Unity at the same time, and with that, introduced an event system that handles input from the user and it sends events to objects in the scene. And it's actually a pretty decent system. So we're going to be looking at this to explore how event systems work, and then explore how we can use this in our games. Now, you've actually previously already seen one way of passing messages, and that's GameObject.sendMessage, which you can see here. And with GameObject.sendMessage, basically, and there's an example down here, we choose what object we want to send the message to, we give it the name of the method we want to call, and then we give it an optional parameter. And it looks on all of the scripts that are on that game object, and if any of them have a method by that name, then it sends the event to them. This has been in Unity for a number of years, and it's sort of a very basic way of sending events. The downsides, though, is that this is kind of a very slow way of doing things. It has a lot of overhead, because under the hood it's actually using reflection. It's asking all of the scripts attached to a game object what methods they have, looking through to see if any of them match what you're looking for. And it has some other limits. So, for instance, it only lets you send one argument with your event to the receiver. So the new event system was a real improvement in that regard, and it also gives you a lot of other useful pieces. And one more thing, they've decided to make the new event system open source, so you can extend it. And I've actually done this for a number of things, like getting input from the Oculus Rift, getting input from the Z-Space holographic display. In both of these cases, you don't have a mouse and keyboard, you have some other way of getting input, so you need to write a custom way of getting that input, and then you can plug that into the existing event system to send events. So let's take a look at the event system, and we'll just start with a blank scene here. And the event system is set up for you by default whenever you add a canvas. So we're just going to start by adding a UI element. We'll just start by adding a button. And when we do that, you can see that a couple things appear. We have a canvas underneath the button, and we also have this event system game object. So let's start with the event system. The event system actually has 3 scripts, and it has 2 types of scripts. This event system component is what controls and manages the whole shebang, the whole event system. And this is the piece that's going to update every frame and that essentially does the polling. So this is kind of our control piece. And then the next 2 things that you see are input modules. And input modules gather input from different sources, and they bundle this input up into an object that can get passed around. So, for instance, the standalone input module is going to get input from the keyboard and the mouse, and it's going to stick that in a event data object that it can then pass around as needed. And we also have this touch input module, which actually, both of these build on top of there's sort of a base input module, and then they sort of implement different things for different types of input. And so we have the event system, we have input modules, and then the other piece is a raycaster. And the raycasters, there's actually a couple of them, they look out into the scene to see what objects should receive the events. So a graphic raycaster is used with graphics, and for instance, an image derives from graphic, from unityengine.ui.graphic. Text also derives from unityengine.ui.graphic. So both of these things are graphics. And so with the graphic raycaster, it's not quite correctly named. It doesn't quite do raycast, but it's the same general thing. Is it takes a look at where your mouse is. So if we go ahead and hit play here, it takes a look at where the mouse is, and it sees if the mouse is over our button or not. And so with these three pieces, we have the EventSystem manager, the input modules, and then the raycaster. Then we have a complete event system. And in the end, whenever the state of the world changes, so for instance, whenever the mouse goes from hovering over nothing to hovering over a button, or whenever the user clicks or presses the mouse or does other things, then those events get sent to the listeners. And in this case, our button is the listener. So we can actually sort of open up and look at what's going on inside of the button. And we can see how it listens for these events. And what I have here is a program called ILSpy, and it actually allows you to open up DLLs, so it open up compiled code and see the C# code inside of it. So in this case, we're actually opening up the unityengine.ui DLL that's shipped with Unity. It lives within the Unity install directory, and we can see all the stuff that's defined within unityengine.ui. And one of those things is button. So we can actually open up the logic for the button component, and this is the script that drives buttons. So this script corresponds to this script right here. And the way that the event systems are implemented is that we use these handlers. And you can see that we have iPointerClick handler, and that tells us that the button responds to pointer clicks, or in other words, mouse clicks or finger clicks, depending on whether you have touch or you have standalone regular input. It also has an iSubmit handler, and that gets called whenever this object is selected and you press the submit button, which by default is enter. And then it has a couple other things. It has this EventSystem handler. It derives from a base class called selectable, and selectable has handlers of its own. So for instance, pointer enter, pointer exit, pointer down, pointer up. So it inherits those events, and then it adds the click event and the submit event. And it implements all those within the class. So for instance, if we go up to the selectable class, the iPointerEnter handler, we can actually click on any of these in ILSpy, and we can see the definition of this interface. So this interface, if we implement it, in our class we have to have a method called onPointerEnter. And if we go back and we look through here, here we go down at the bottom, we have onPointerEnter. And what it does is it sets a bool, the pointer is inside of this element, and then it calls this other method evaluate and transition to selection state. So that's where when your pointer enters an object, it goes to that highlight state. And you can actually go through and you can click on this code and you can kind of follow through all the things it's going to do. But essentially what it's going to do is it's going to transition the color. And we can't see it super well with the buttons. I'm just going to make the highlighted color a bit more obvious. I'll make it some kind of like bright gold. So that when we hover over the button, it transitions from its base color to that highlight color. And coming back to our selectable and to our button, the way it does it is by implementing these interfaces. Now, the awesome thing about this is there's no magic here. Everything that they've done in the button class, you can also do in your own classes. So for instance, you could make your own button class that behaves a little bit differently than the built-in Unity buttons. And in fact, we can turn anything in our game into a button. And we're going to be doing that in just a minute. We'll turn just a random cube in our scene into a button that can be hovered over, that can be clicked on, and that can have actions associated with it. So let's take a look at that. And I have an example scene set up here. And in this scene, I have a canvas and it has a button. And it's set up just the same as we saw in that last scene. So when I hover over it, it gets events. Now, I also want to turn this door into a button. such that when I hover over it, the door turns that same nice gold, and when I click on it, the door starts an animation and opens. So we're allowing the user to better interact with this scene. And we have all these same pieces. So our event system, we have the base event system, we have the standalone input module, we have the touch input module. If we want to be able to click on objects in our scene, we need a different raycaster. Because remember, what we have by default is this graphic raycaster, and this is attached to our canvas, so this is specific to our canvas. If we want to look out into the scene, we need to go to our first-person controller, and we need to add a physics raycaster. And this will do what we've seen in other videos is a more regular raycast. It does physics.raycast out from the forward direction of our camera, and then it's going to see what our mouse is hovering over in the scene, and then just the same way that we had with that button in the canvas, we can take any object in our scene and attach a script and turn it into a button. So once we attach that physics raycaster, and by the way, you can just go to add component, and if you just look for raycaster, you'll see the three kinds. Physics raycaster is used for 3D objects, physics 2D raycaster is used for 2D objects, so it's used for sprites, and then graphic raycaster is used with canvases. So we have our physics raycaster, and if we go into this scene, I've already set up our door script such that when I hover over it, it changes color. And that's just to let the user know that this is an interactable object. It doesn't do a nice smooth transition, it just instantly changes color. If I wanted it to be smoother, I could do things with coroutines and whatnot, but for now, this is good enough. It just lets the user know that this is something that can be interacted with. So what we'll do in this video is we'll take that starting script, which doesn't really have a lot, and we're going to add the ability to click on it. So what we have so far is we have a link to the renderer that we're going to be changing color. We've set what our highlight color should be, and internally we take the base color of the door and we just save it out. Then when the pointer enters, when the user hovers over the object, we swap out the door renderer material color to the highlight color, and when the pointer leaves, we set it back to the base color. And we can see this reflected in our door as our door button. So we've set our door renderer, and that's the thing that actually is red, and then we've set what the highlight color should be. So next we need to add the ability to click. And the first thing we need to do is we need to add this using directive, using Unity Engine.EventSystems. EventSystems then, in turn, is what gives us access to iPointer exit handler, iPointer enter handler, and all the other things that go with the event system. And if we pull ILSpy back up for a moment, we can see that under Unity Engine.UI in that DLL, we have this Unity Engine.EventSystems, and that is exactly what we're pulling into scope here. And within Unity Engine.EventSystems, we'll see that sure enough, we have all of these different handlers. So I scroll, you can get scroll input, you can get drag and drop input, all kinds of stuff. And we also see all the other parts of the event system. So for instance, there's our physics raycaster. We have our pointer input module, all these things we've seen. You can actually open them up and take a look and see what they have inside of them, which is pretty cool. So we've imported, or I guess we've said that we are using the event systems. And then if we just hit I, it's going to pull up all the various interfaces, and we can decide what interface we want, and in this case we want iPointer click. Then we can right-click, we can choose Implement Interface. And now we have to decide what should happen when we click. And in our case, it's very simple. When we click on the door, we have an animator associated with that door, and I just want to turn the animator on, and that'll start the animation. So we're going to do animator, we're going to do get component animator dot enabled is true. So whenever we click, that's what's going to happen, and that's it. We've now added the ability to respond to clicks, and we've added the ability for the door to open when you click on it. Now one cool thing is, and you may see this minimized, but down at the bottom of the screen, whenever you start implementing this event system stuff, it'll actually tell you what events are being intercepted by which scripts. So our door button is intercepting these events. If I go ahead and hit play, I mosey on over to the door, and I click on the door, and the door is going to open, and then I can walk through it. So I've added some really nice functionality to my game, and I've done it using event systems. The door doesn't have to poll every frame and ask, where is the mouse, what is the user doing, has the user clicked on me? It can just be passive, and it can wait for the event system to tell it the user has clicked on you. So we have a lot of pieces, and I'll just take a quick look back through them. But what we have here is a complete event system that's given to us by Unity, and that we can extend on our own. Oh yeah, and before I forget, one more thing. I wanted to show you that you can, in fact, extend this, not just in terms of the receiver, the listener, but also in terms of these input modules. So I had mentioned that previously I've worked on projects where I've wanted to get input from devices that don't have a mouse and keyboard. These two input modules, the standalone input module specifically gets input from the mouse and keyboard. The touch input module gets it from touch, so touch devices, fingers, essentially. You can also write your own, and let me show you real quick. This is a framework that I'm working on for a client where they wanted the ability to have a bunch of objects in scene and have the user be able to interact with them while they're moving around. And in this case, we have our regular event system, and I've set this up to work with VR. So I've turned off our standalone input, I've turned off our touch, and I've added this look input module. And this is something that someone had put together on the forums that I took what they had already done and sort of tweaked it, added a few things so that it would work for our use case. So our look input module actually gathers input from where you're looking. So if I go ahead and hit play, then we can see the left and right eye. This is sort of an emulation of the Rift. And it'll take where the user is looking such that when they look at an object, the object changes color, and if they look at it for a certain amount of time, then it sends essentially a click event. So if you hover over an object for long enough, it sends a click event to it, and this whole thing uses that same event system. So if we go ahead and we click on this, we are in fact using just a regular old button on a canvas, and then we are interfacing that with VR input from the Oculus Rift. So it's a highly extensible system. There's a lot that can be done with it. And just to run back through what we've talked about, with the event system, we have a control object that does some polling. It regularly checks what the state of the world is. And when the world changes, it gets input, so it figures out through the standalone and touch input module, or through your own if you add it, what the user is doing. Are they clicking on the mouse? Have they moved the mouse? Have they turned? And then it sends events as appropriate to objects in the scene. And it figures out which object to send the events to, either by using the graphic raycaster, or by using other kinds of raycasters, for instance, a physics raycaster. And then the receiving object, basically what it does is it checks to see, is there an object that intercepts the kind of events I'm ready to send? So in the case of our door, it checks to see, is there an object capable of getting pointer clicks, pointer enters, and pointer exits, and if so, it then sends that event to your script. And inside your script, all you need to do is pull this event systems into scope, and then you need to implement a couple of interfaces. And once you do those, these each come with methods. And within your method, you can have any logic you want. So when the user clicks on an object, you can respond however you'd like that makes sense for your game. And essentially what it's doing, by the way, when you implement these events, the event system is going to just check. It's going to take your current game object, and it's just going to say, okay, is there any component that implements the iPointer enter handler? And if that's not equal to null, so it's going to do, this is kind of pseudocode, but it's going to do something like this, then it's going to take that game object, get component, iPointer enter handler, and it's going to call onPointer enter. So that's how it uses the concept of interfaces in C# to very quickly find objects that can handle these events, and then call the associated method to receive these events. And that, in about a 20-minute nutshell, is how event systems work, and how they're implemented in Unity, and how you can use them to turn any object in your scenes into a button.